Okay, students, with that idea, we will go for the question. So, we need to find the volume of this shape. So, this is not a cylinder shape. This is not a cylinder shape because if you observe directly, we have two cylinders. Inside the tube, you have a cylinder shape. Outside, you have a cylinder. But we are not using the cylinder shape. We are using the primary equation because it's not a single cylinder. Okay. So we need to find out. So if you go for the basic equation, cross-sectional area into length. So the length of this cylinder shape concrete tube is 100 meters. So first of all, we need to find the cross-sectional area. Okay, cross-sectional area means the area of this part. So we have two different radius of circles. So using that we can find the cross-sectional area. So we have some working here. So we didn't go for the cross-sectional area directly. We find it separately and we'll substitute. So cross-sectional area equal pi r1 squared minus pi r2 squared. Area of the larger circle minus area of the smaller circle. So the pi is common. So r1 squared minus r2 squared. So r1 is larger circle, r2 is smaller circle. So the diameters are given 43 and 50. So pi, if you substitute the diameter, larger circle is 50 over 2 all squared. Smaller circle, that is 43 over 2 because the diameter is 43. Okay, so then a squared minus b squared, we can go for that. A squared minus b squared, 50 over 2 minus 43 over 2, 50 over 2 plus 43 over 2. Okay, and then next (22 over 7) into 50 over 2, 43 over 2, denominators are same. So 53 minus 50 minus 43, it's 7. So 7 over 2. So then 50 plus 43, that is 93 over 2. So now we can do the simplification. 7 times 1, 7 times 1, 2 times 1, 2 times 11. So 93 into 11. So 93 into 11. 9 plus 3, 12. 1 remaining, 3. So 1023. 1023 over 2. 1023 over 2, that is 511.5 centimeter square. That's 511.5 centimeter square. So that is the cross-sectional area of this solid shape. So we have the cross-sectional area and we have the length. Length is 100 centimeter. So we can go for the volume. So volume 511.5 into 100. So 51,150. 51,150 centimeter cube. The volume of the concrete used to make this concrete slab. Okay. Fourth question related to a prism. A prism is given, right angular cross sectional prism is given, and the length of the prism is 50. So directly we can find the volume, cross sectional area into length. Cross sectional area half into base into altitude into length. So half base, the right angular cross triangle is given, so we can take the base and the perpendicular height. So 18 into 4, you can change it, 14, 18, you can change it. So into length is 50. Okay, if you divide 2 and 18, 9. So 9 into 14, 36, 12, 126 into 5, 0, 3 balance, 10, 13, 1 balance, 5, 6, another 0 is there. So 6300 centimeter cube. Okay, go for the fifth question. A metal cylindrical shape iron rod. A metal cylindrical shape iron rod. Draw a small figure, then you can easily understand the data. Metal iron rod, cylindrical shape iron rod with radius 1 centimeter. Radius is 1 centimeter and the length is 80 centimeter. Is melted and made another cylinder. So this iron rod is melted and another iron rod is made. Another iron rod is made. So made a cylindrical shape iron rod with 2 centimeter radius. Now the radius is 2 centimeter. So if you increase the radius, the length, I think it will short with the previous length. Okay, find the length of the iron rod. So a solid metal is melted, another solid shape is created. So the initial volume of the material what we used is equal to volume of the new shape. So that is our idea. So volume of what do you say? Volume of initial iron rod. Volume of initial iron rod is equal to volume of new iron rod. So before we are using the basic equation, those are in cylindrical shape. Before we using the equation of the shape, we are going to use the equation. What is the connection between the two solid shapes? The connection is one of the material is used to create another material. So for those both materials, the volumes are same. So what is the initial iron rod shape? That is pi r1 squared h. So why I put pi r1 squared h? Because the radius are different. The basic equation is pi r squared h because it's on the cylinder shape. So the another one, pi r2 squared h1. So we can use h1 h2. because the length and the radius are different, but the shape is cylinder. So pi r squared h, pi r squared h. If we put pi r squared h, pi r squared h, we can cut it off on the both sides. That's why we differentiate it. So pi, we don't want to represent pi. Radius is 1, so 1 squared, and the length is 80. Pi, now the radius is 2 squared. We'll put the height as h. Okay, so if you find separately, you need to substitute pi and you need a simplification. So you need a time for simplification. If you take the connection with the equation, so it is easy to simplify. So that's why we use this method. So pi, so we can cut it off. So 1 into 80, that is 80. So 2 squared, 4 into h. So h equal 80 over 4, that is 20 centimeter. The length of the new cylindrical rod is 20 centimeter. So there is a main portion, main theory, main concept of volume is there in the question. One of the solid shape is melted and another shape is created. The connection between two shapes are, the volumes are same. So now we can go for the all the exercise. You can do all the exercise related to volume of this lesson.